Okay guys, welcome back again. In today's video, we are going to solve question 7 from DBE from paper 1 from November 2021 past exam. Okay, in the previous video, we did question 5 and question 6 still on grade 12 functions. Okay, so we are going to do question 7 on grade 12 functions. Okay, this is the question. So you have from 7.1 up to 7.5. So you have 5 questions to solve. Okay, let's start on the next slide. So we start with 7.1. This is the question. Write down the coordinate of B and D. And this question is 2 marks. Okay, let me get the question again. So this is question 7 from November 2021. Okay, so we are still doing questions from DBE from November 2021 past exam. Okay, this is the question, question 7. The graph of f, the question is given for the graph of f. The graph of f is drawn below. The parabola cuts the x-axis at B and D and the y-axis at G. C is the turning point of f. Line AE has an angle of inclination of theta and cut the x-axis and y-axis at A and E, respectively. T is a point on F between B and G. So this is the graph of F. It is a parabola. You can see this one. And the parabola cuts the x-axis at B and D. There's B and there's D. So it cuts the x-axis at B and D. So you know that B and D are your x-intercept. And the y-axis at G. So it cuts the y-axis at G. So this is your y-intercept. So you have your x-intercept there and your y-intercept there. C is the turning point of F. There's C, the turning point of F. Line AE has an angle of inclination of theta. This is the line AE. You can see the line AE. You can see it has an angle of inclination theta. Okay. And this line cuts the x-axis and y-axis at A and E, respectively. So it cuts the x-axis at A and the y-axis at E. You can see T is a point on F. There's T, a point on F between B and G. There's B and there's G. Okay. Now 7.1, write down the coordinate of B and D. The question is 2 marks. You know that at the x-intercept, y is equal to 0. So you can say to find the x-intercept, let y equal to 0. But you are given the equation of the graph in this way. You can see this is the equation you are given. Straight away, you can see what your x-intercept are when you are given the equation of the parabola in this form. I don't know if you can see that. Okay, before I can continue solving this question, I want you to know the different type of the equation of a parabola. When they are given in this form and the other form, you should be able to tell from the equation what are the letters representing. Okay, let's see that. So the equation of a parabola can be given in this form. Can you see? It can be given as y is equal to ax squared plus bx plus c. Okay, when it's given in this form, you know that c represents your y-intercept. Because if you plug 0 there and 0 there, you remain with y equal to c. And c is your y-intercept. And you know that at the y-intercept, x is equal to 0. So this equation of a parabola tells you that c is the y-intercept. And the equation of a parabola can also be given in this form, like this. So if it's given in this form, you know that your p and q, the value of p and q, are the coordinate of the turning point of the graph when it is given in this form, right? Or the equation of a parabola can be given in this form. When it's given in this form, you know that R1 and R2 are your x-intercept. And this is the form we have here. You can see. Okay. So you don't need to say that to find the x-intercept, let y equal to 0 and then you solve for x-intercept. So you go all the way doing all those calculations. The simplest way is to look at the equation and you can tell straight away what the x-intercepts are. Okay, we said that this equation is given in this form. So your A, you can see your A is equal to 1. There is an invisible 1 there. So now, what are the x-intercepts? The x-intercept B and D. What are the coordinates? Because the question is to find the coordinate of B and D. And B and D are the x-intercept of the graph. So when you solve for B, you can see that B is equal to -4 and 0. When you solve this part, you make it equal to 0 and you solve for x, you are going to find that x is -4. So the coordinate of B are -4 and 0. And D, the coordinate will be 6 and 0. When you solve this part, you make it equal to 0. So the coordinate will be 6 and 0. So you can tell that B has got a negative coordinate and D has got a positive coordinate. When you look at the graph, you can see that B is on the negative side and D is on the positive side. So you have to make sure you write down the coordinate the right way, because you can see -4 for B and 6 for D. And now 7.2, the question says calculate the coordinate of C, and the question is 2 marks. Okay, so when you look at the question, it says C is the turning point of F. You can see C is the turning point of F. You can see there. Okay, to find the x coordinate of C, you can use this formula. X is equal to -b over 2a. So this formula can give you the x coordinate of C. When you get the x coordinate of C, you take that value, you plug it inside there, you are going to find the y coordinate of C. Okay, so this formula can be pulled out from the quadratic formula. Another formula that you can use is this one. You can use differentiation if you have done calculus. So you take f prime, you make it equal to 0 and you solve for x. So when you find x, you plug it inside f and then you are going to find the y coordinate. Okay, so you can use this or this one to find the x coordinate of the turning point. Okay, I'm going to use this method. This is very simple. You can see when you are given this graph, you can see C is the turning point, right? And you have B and D, which are the x-intercept. The x coordinate of the turning point is halfway or between B and D. So it's somewhere there. So what can you do? You can take the x coordinate of this and the x coordinate of this, you add them up and you divide by 2. You are going to get the x coordinate of C. Let's do that. So x is equal to, you take the x coordinate of B, which is -4, right? Plus the x coordinate of D, which is 6, over 2. You divide them by 2. Can you see? You take the x coordinate of B and the x coordinate of D, you add them up and you divide by 2. You are going to get the x coordinate of C. So you can see C, its x coordinate is in between there. So it's between B and D. So this is why I use this formula. So you can use this formula or this one to find the x coordinate of the turning point, which is C. Okay, and this is going to be equal to, can you see 6 minus 4 is 2, 2 over 2 is 1. Okay, you can see that. And now to find the y coordinate of C, you take f1, f of 1, right? So it's going to be, this is equal to, you have the bracket there and you replace your x with 1. So you plug 1 wherever there is x. So it's 1 plus 4. You open another bracket, you put 1 there, minus 6, okay? And this is equal to, this is 5 and this is -5. Can you see 1 plus 4, 5, 1 minus 6, -5. And this is going to be -25. And so the coordinate of C are 1 and -25. So 1 and -25. Now let's move on to the next question. Let me put a line here. Okay, I'm going to do 7.3 here. what is the question saying? 7.3, write down the range of f, and this question is only 1 mark. Let me get the question again. This is the question. So this is f. Can you see? It is a parabola. You need to write down what? The range of f. This is f. So the range of a function, or the range of f, is found on the y-axis. So you take all the values of y that exist for this graph. Okay, so you start from there. At C, there is a y value there all the way up, so all the way to positive infinity. Can you see the graph still continue? So it's from there all the way to positive infinity. When writing the range, you always start from the bottom to the top. When you take the domain, you start from left to the right. Okay, the domain from left to the right, and the range from the bottom to the top. Okay, so we start from there. Can you see the coordinate of C, which is the turning point, are 1 and negative 25. So you know that at y you have negative 25. So you start from negative 25 all the way to positive infinity, or all the way to infinity. Okay, so the range of f, you are going to write it as y element of negative 25 all the way to infinity. Okay, and you make sure you have a square bracket there. Negative 25 is included. You can see it's included when you look at the graph. You can see it's included. It's there. It's included on the graph. This is why you have a square bracket there. And you have a round bracket there because you don't know what infinity is. Because this graph still goes on and on. You don't know what infinity is. You must have a round bracket there. And you have a square bracket there because negative 25 is also included in the range. Okay, so you can write the range like this, or you can write it as y greater or equal to negative 25. So you make sure there is an equal sign there because negative 25 is included. So from negative 25, from the bottom to the top, this is what I wrote here. So you can give the range like this or like this. And now 7.4, let me get the question again. So this is the question 7 from November 2021. Okay, so this is the question. And now the question is, given that theta is equal to 14,04 degrees and the tangent to f at t is perpendicular to AE. So the angle of inclination that the line AE is forming with the x-axis, the values are given. You have them there, 14,04 degrees. Okay, and there is a tangent to f at t. So the tangent is touching f at t. It goes like this. Okay, we are going to draw it. And that tangent is perpendicular to AE. This is what they are telling you. So the tangent touches f at t, and it's perpendicular to this line AE. So it goes like this. Okay, so it's perpendicular, meaning it's forming an angle of 90 degrees with the line AE. Okay, now question 7.4.1. The question says, calculate the gradient of AE correct to 2 decimal places. And this question is only 1 mark. Okay, so the question is very simple. This is why the question is even 1 mark. Okay, we are going to do it. So we need to calculate what? The gradient of AE, the gradient of this line AE. So when there is a line which is forming an angle of inclination with the x-axis, to get the gradient of that line, when it's forming an angle of inclination with the x-axis, you have to use this formula. This is the formula. The gradient of the line, so m for gradient. I want you to know that m is for gradient. So the gradient of a line is equal to the tangent of the angle of inclination. Okay, so you take the tangent of the angle of inclination, and that will give you the gradient of that line. So this is the line. It's forming an angle of inclination theta with the x-axis, right? So to get the gradient of this line, you take the tangent of that angle. So the gradient of the line is AE. You can see the line is AE. Let's call it by the name AE, right? And this is equal to tan of what? Theta. Theta is the angle of inclination, okay? And so the gradient of that line is equal to the tangent of what? 14,04. You are given the value of the angle of inclination, that angle, 14,04 degrees, okay? So this is how you do. And this is equal to, when you take your calculator, let's get the calculator. You are going to plug this inside the calculator and you get the value. So the tangent of 14,04, and this is equal to 0,25. So to 2 decimal places, okay? So 0,25, okay? So this is the gradient of this line, okay? So now let's move on to the next slide and let's do the next question, which is 7.4.2. Okay, now 7.4, we have this question from the previous slide. You remember it? It says, given that theta is equal to 14,04 degrees and the tangent to F at T is perpendicular to AE. Now we are solving 7.4.2. So we did 7.4.1 in the previous slide. Now it's 7.4.2. The question says calculate the coordinate of T. And this question is 5 marks. Okay, this is the graph we are given from the question. Now let's draw what they are telling us. So they are telling us that there is a tangent to F at T. There's the point T. So there is a tangent like this. You can see the tangent in red. Can you see? So at the point T there, it's touching F at T. So this is the tangent in red and it's touching the graph of F at T. So this is what they are telling you. And the tangent to F at T. Now this tangent is perpendicular to AE. So let's do that. It's like this. Can you see? This means perpendicular. So the angle there is 90 degrees. Okay, I hope you understand that. The question is to calculate the coordinate of the point of contact. This is the point of contact between the tangent and the graph of F. T is the point of contact between the tangent and the parabola. Now there is a formula, okay? I know you have some other method from grade 11 that you can use. Now let's use this method for grade 12. This is the formula that you have to remember. The gradient, let's say M for the gradient of the tangent. So the gradient of the tangent. Remember the tangent is a line. So this is a linear function. You can see it's a line. So you take the gradient of the tangent is equal to the first derivative. You take the first derivative of this graph. So when you have the equation of this graph, the parabola, you take the first derivative of that equation, the equation of the parabola, you make it equal to the gradient of the tangent. Remember the tangent is a line. So it is a linear function. We need to get the gradient first of the tangent and we don't have it, but we can get it. Using this information, you are told that AE, the line AE, is perpendicular to the tangent. And you know the gradient of the line AE, you found it in the previous question. According to this information, you know that when two lines are perpendicular to each other, the gradient of one line times the gradient of the other line is equal to -1. So the product of the gradient of this line and this line, which is a tangent, must be equal to -1 because they are perpendicular to each other. So when two lines are perpendicular to each other, the product of their gradient is equal to -1. Okay, and you have the gradient of the line AE. You calculated it using tan of theta. So theta was 14,04 and you found that the gradient of this line was 0,25. You remember it when we did it in the previous question 7.4.1. Okay, and so this gradient times the gradient of the tangent is equal to -1 because the two lines are perpendicular to each other. The gradient of the tangent, which is equal to, you divide by 0,25 on both sides. So you divide by 0.25 this side, you remain with the gradient of the tangent, and you divide the -1 by 0.25, you find that the gradient of the tangent is equal to -4. So now we have the gradient of the tangent, which is equal to -4. Now let's take the first derivative of the equation of the graph of f. So the graph of f, this is the equation that you are given. Remember from the question, you can see it. I hope you can see it. This is the equation that you are given for f. You can see f of x is equal to that, right? This is what I have here. Okay, so now we need to take the first derivative of this equation. So first, we need to expand the bracket. So f of x is equal to, this is x squared, and -6x plus 4x, it's going to give you -2x, plus 4 times -6, it's going to give you -24. So when you expand the bracket, this is what you do. You get this. I hope you can see that. So x times x, x squared, you can do all those things. 4, and you get this and the middle term. Okay, now let's take the first derivative. You must know this from calculus. Okay, so this is going to be equal to 2x minus 2. Okay, and this is a constant. It's equal to 0 when you take the first derivative. So now this is the first derivative of the equation of the parabola. Okay, now we can use this formula. This is the formula to remember. Always remember this formula. Please have this formula in mind when you are dealing with a tangent that is touching a graph at a point. So this formula will help you to find the coordinate of the point of contact. The tangent has got a gradient of -4. We calculated it. Okay, so -4 is equal to the first derivative. This is the first derivative, 2x minus 2. I hope you can see that. So I'm using this formula. This is the tangent, -4. First derivative is this one. You take your -2 to the other side. You're going to have 2 minus 4. It's going to be -2 is equal to 2x. And so x is equal to, when you divide by 2 on both sides, x is equal to -1. I hope you can see that. You divide by 2, you get x. You divide by 2 there, you get -1. Okay, so this is the x coordinate of the point of contact. Now to get the y coordinate, let's carry over here. Let me make a line here. Okay, so you are going to take f of -1, right? Or you can plug the -1 inside the equation of the tangent, but you are not given the equation of the tangent. You only have the equation of the graph. Let's use this one. So you can plug the -1 inside this equation or this one. So this is the same as this one. These two, they are the same. This is just an expansion. When you expand the bracket, you get this. Remember, this is the same. So you can plug the -1 in this one or in this one. You are going to find the same result. Let me use this one. So this is going to be equal to, you have a bracket there. You plug your -1 in the place of x. So -1 plus 4. You close your bracket. You open another bracket. You plug your -1 in the place of x. So you have -1 minus 6, right? And you close your bracket. So remember, this is your y. So y is equal to, this is 4 minus 1, it's 3. This is -1 minus 6, this is -7. So it's -7 times 3, which is -21. And so the point of contact T, the coordinate of this point is -1 and -21. You can see -1 and -21. So these are the coordinate of T. So this is how you do this type of questions. Okay, always have this in mind. Please have this in mind. Keep it in mind whenever you are dealing with this type of question. This will help you. Okay, now let's move on to the next question. I believe it is the last question. Okay, now it's 7.5. So the question is, a straight line G parallel to AE cuts F at K and R. Calculate the x coordinate of R. So you have a straight line called G, which is parallel to AE, and the straight line cuts F at K and R. These are the coordinates of K. The question is to calculate the x coordinate of R. Okay, now this question is 6 marks. Okay, let's illustrate what they are telling us in this question. Okay, so this is the graph. Now there is a straight line called G, which is parallel to AE. This is AE, and there is a line which is parallel to AE, and the line is cutting F. This is F. It's cutting F at K and R. The coordinate of K are -3 and -9. Okay, let's predict this. Can we predict it? Okay, the point K will be somewhere. You remember the coordinate of this point, the point of contact, when we calculated it in the previous question was -1 and -21. So if you can predict this, this is at -1. So -1 there. So now -3, it will be a bit beyond. So -1 for T is there. Now -3 for K will be somewhere there. If I can predict it, somewhere there. And -9 is there. Remember the y coordinate of T was -21 from the previous question. So the point K is there. So -3, -9, if we can predict it. And this point is K. And now there is a line cutting at K like this, going there, cutting F again at R. So that point is R. Okay, this is what they are telling you. You can see this line is called G. You are told it's called G. So the line is parallel to AE. You can see this is AE and this is the line G. So it's parallel to AE. Okay, now the question is to find the x coordinate of R. You are given the coordinate of K. They are there, -3, -9. So K and R are the point of intersection between the graph of F and the line G. Okay, to calculate the point of intersection between two graphs, what you do is to take the equation of this graph, you equate it to the equation of the line. We have the equation of the graph of F. We need to find first the equation of the line G. Okay, when we found the equation of G, we are going now to equate the equation of G to the equation of F. And then we are going to solve for the point of intersection. Okay, first of all, let's get the equation of the line G. Okay, to find the equation of the line G, you are going to use this equation. Okay, you can use this one or this one, right? The one in black or the one in red. So this is called a point slope form, this one. And this is called a slope intercept form. You can use either of them to find the equation of this line G. When you find the equation of the line G, now you are going to make it equal to the equation of the graph of F. And so when you make them equal to each other, you can now solve for the coordinate of the point of intersection. The point of intersection are K and R. Okay, let me use this one. You can use this one or this one. So I'm going to use this one. Okay, in this one, M is your gradient. Even in this one, M is the gradient. So remember, what is M equal to? M for G. So the gradient of G, we are doing this. So the line is called G. So the gradient of G is equal to what? If you can remember from the previous question, the gradient of this line was 0,25. We calculated it in the previous question. So when two lines are parallel to each other, they also have the same gradient. And so the gradient of this line will also be equal to 0,25. Okay, I hope it's clear there. Okay, now to get the equation of the line, using this equation, we are going to use a point on the line. So we can use this point K. We are given the coordinate -3, -9. Okay, let's use the point K to find the equation of this line, because you know K is also on the line G. Okay, so we are going to use this one. Y, it's minus, you are only replacing your y1 and x1, only y1 and x1. So it's y minus, what is your y1? Remember, the second coordinate is your y and the first coordinate is your x. So your y1 is -9. Okay, I have -9 there, which is equal to, you have M for the gradient, 0,25. You open your bracket, x, you only replace your x1. Okay, what is your x1? -3. There's -3 in bracket there, and you close your bracket. Okay, I hope you can see that. And so you have y, this is plus, so y plus 9 is equal to 0.25, and this is x plus 3. You can see that, okay? And so y is equal to, you have 0.25 times x, which is 0.25x, and then you have 0.25 times 3, which is plus 0.75, okay? Plus 9, you bring it to the other side, it becomes negative 9, okay? And so y is equal to 0.25x, and what is this equal to? You can use your calculator. So you have 0.75 minus 9. Okay. So it's negative 8.25. Okay. Negative 8.25. Okay. So this is the equation of the line G. So let's call it G is equal to this. Okay. The line is denoted by G. Okay. So we say G is equal to this. And the equation of the graph of f is also given. This is the equation. You can check it from the question. Okay. We have the equation of the two graphs, the line and the parabola. They are intersecting at K and R. So the line and the parabola are intersecting at K and R. Okay. So first of all, let's expand this so that we can solve for the coordinate easily. So f of x, remember, is equal to this x squared. When you multiply there, now you have the middle term, which is 4 minus 6. So it's negative 2x. And you have 4 times negative 6, which is negative 24. Okay, when you expand the bracket. Let me carry over here. Let me put a line there. So to get the coordinate of the point of intersection, we are going to equate the two equations because they are cutting each other, or they are intersecting. Okay, so the equation of the parabola is this one, x squared minus 2x minus 24. This one is equal to the equation of the line G. This is the line G. This is the equation, right? You have it there. Okay, so you equate them and then you solve for the x coordinate. So the question is only asking for the x coordinate of R. Okay, we can get it using this formula. Okay, now let's put everything on one side. So you have x squared and you have this and this. They are like terms. Can you see negative 2x and this? You bring this to the other side, it becomes negative 0.25x. So this becomes negative 2, negative 0.25, which is negative 2.25, negative 2.25x. Okay, and you have this and this. They are like terms. You bring them to one side. So it is, let me use a calculator so that you can see that. So on this side, you have negative 24, right? And you bring this, it becomes positive 8.25, right? Which is equal to, so this negative 15.75. And you remain with 0 on the other side. So you have brought everything to one side. And now you have this. Okay. So you can see you have decimal numbers. Okay. The quickest way to do is to use the quadratic formula, because you can see you have decimal numbers. If you want to factorize this, it will be stressful. Okay, so we use the quadratic formula, this one, okay, to find the x coordinate. And so x is equal to this when you plug all the values inside. Okay, now what you want to do is to use your calculator. You just plug in all those values in your calculator. Okay, let me use the calculator. Okay, this is our calculator. So you have this, you have negative, in bracket, you have negative 2.25. Okay, let me just plug everything the way it is. And now you have plus and negative there. So let's start with plus, and then after that, we are going to change it to negative. Okay, so you have square root, in bracket, you have negative 2.25 square. Remember that. It's now negative 4 times 1. I hope you can follow. Times negative 15.75. over 2 times 1. So it's 2, but let's just put everything the way it is. Okay. Okay, now you have 21 over 4. In decimal, it's 5,25. 5,25. Okay, so x is equal to 5,25. Okay, and what if we change now that to negative? We used plus. Let's change it to negative. Okay, let me do this. You shift back. Let me change it. We have plus there. Now let's delete it and put negative. Okay, the answer is negative 3 when you press equal. Can you see the negative 3 is actually the coordinate of k? Can you see? So this tells you that this is the coordinate of r. X is equal to negative 3. But the question was only asking for the x coordinate of r. So make sure you said that x is not equal to negative 3 like this. You put a line there to say that x is not equal to negative 3. So the x coordinate of r is only 5,25. Okay, so this is how you solve this question. Very simple, right? Okay, I hope the video was helpful. If you find some value in these videos, as always, please appreciate that with your likes. I'd like to see your comment in the comment section. And if you want to be part of this channel, don't forget to subscribe to the channel and activate the notification bell so that you can have these videos coming your way. As for now, we are done. I hope to see you in the next video. Okay, bye.